Dear students, now we are going to discuss binary multiplier and its methods in detail. Let's start with the definition of binary multiplier. It is a combinational circuit that performs the multiplication of binary digits. The binary multiplication process is similar to the decimal multiplication. The binary rules for multiplication are 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. As we know that anything is multiplied with 0 is always 0. Correct? So here we can consider the example of 2-bit by 2-bit multiplier. Here the first one is the multiplicand, the second one is the multiplier. Similar to our decimal multiplication process, here we are going to multiply the multiplicand by each of the bits of multiplier, which is starting from the least significant bit. So here it is the least significant bit 0. So 0, 0 and then 1, it is multiplied with 1, 1 as like this. Then we have to add. Okay, the answer for this multiplication is 1, 1, 0. Okay, so from this process we come to know that, so consider this 2-bit multiplier. So A1, A0. Here it is least significant bit. Okay, B1, B0. It is multiplicand, it is multiplier. So first process is we are going to do partial fraction. So partially we are going to multiply with each bits of the multiplier. So A0, B0, A1, B0. So here the first step is what? Partial products by each bits of the multiplier. Okay, then shifting to the left side. Okay, so if you are moving on to the next bit of the multiplier, obviously we have to shift the position of the partial products. Okay, so the next step is what? Shifting operation. So and finally we are going to add all the values. So here 3 steps are to be followed. First one is partial product, next one is shifting, and third one is addition. Okay. There are two multiplication methods available for binary multiplier. The first one is multiplier using shifting method. The second one is parallel multiplier. Let's discuss one by one in detail. Multiplier using shifting method. In this method, we are going to follow 3 steps. The first one is partial product, then shifting, finally addition of the partial products. So here, it is the diagrammatic representation of this multiplier using shifting method. Multiplicand is stored in the A registers and here multiplier is stored in the B register. X0, X1, X2, X3, X4. This X register represents the final output. Here we are going to use 4-bit parallel adder to add all the partial products. Okay. So as we know that if the multiplier bit is 1, then the multiplicand is same as that of partial product. Correct? If the multiplier bit is 1 means the partial product is same as that of the multiplicand. Correct. If the multiplier bit is 0, then the partial product is 0. Do you all remember this? Here, if the multiplier is 1, so whatever values are stored in this multiplicand register, that is A register, we can keep the values as such. 1 is multiplied with the multiplicand, we can get the same multiplicand as the partial product. If the bit of the multiplier is 0 here, okay, so all the terms become 0. That's what given here. Okay, so if the multiplier bit is 1, then the multiplicand is same as that of the partial product. If the multiplier bit is 0, then partial product is 0. So after getting the partial product, it is shifted 1 bit to the left of the previous product. So we have to make a shift to the left side. So this process is continued until all the multiplier bits are used. So once all the multiplier bits are multiplied with the multiplicand, then only we have to stop this step. Okay, so finally we have to add all the partial products together to get the binary multiplication value. Okay, so this is how we can perform the multiplication operation in binary values. Multiplier using shifting method is a very simple method and it requires less number of hardware. So its complexity is very less. These all are the major advantages of shifting method, but there are some limitations. Limitations of shifting method. In order to perform 4-bit binary multiplication process, the shifting method requires 4 cycles of addition and shifting operations. Obviously, it slows down the operation of multiplication process. So, its operation is slower using shifting method. In order to overcome this limitation, we go for this parallel multiplier process. Okay. Parallel multiplier requires 4-bit binary adders and 16 AND gates. The generation of partial products and their additions are performed in parallel. That is, simultaneously we can perform the partial products and their addition in this parallel multiplier. So this is what the 4-bit by 4-bit binary multiplication process. So here we are going to perform the partial product as well as the addition operation all together simultaneously. So here we have to multiply these things B0 A0, B0 A1, B0 A2, B0 A3. Okay, so while doing this partial product, the B1 is multiplying with this 4 bits. Simultaneously, B2 is also multiplying with this 4 bits. B3 is also multiplying with this 4 bits. So, all these operations are performing simultaneously in parallel multiplier. So, here we can take this A0, B0 as a P0. So, here P0 represents the output of the product. The LSB of the output of the product, we can directly take it down. And here these two partial products are getting added using parallel adder. Okay, so next, likewise, all these operations are done simultaneously in parallel multiplier. Okay, so here we can get the values like this P7, P6, P5. This is the final answer of this product. So this is given like this. Parallel multiplier requires 4-bit binary adders and 16 AND gates. So here partial products can be implemented with a group of 4 AND gates, and the 4-bit partial products are added using 4-bit parallel adders. All these operations are performing simultaneously inside the parallel multiplier. So the major advantage of this parallel multiplier, we can say, since the generation of partial products and their additions are performed in parallel way, that is simultaneously happens. Okay, the multiplication result will be produced immediately at the output. So we can get the multiplication output very immediately. The speed of multiplication process is increased in this parallel multiplier. But there is one drawback. Here we need more number of hardwares to perform this parallel addition and multiplication. Correct? Because we need 4-bit binary adders and 16 AND gates for performing 4-bit multiplication. So if the number increases means the hardware is also getting increased. That is the major drawback.